Hello, welcome to this video all about indices today. Now an indice or indices is just a posh word of saying powers, so this word can just be used instead of powers. So we're going to start off some fairly basic stuff, i.e. what is a power, and we're going to move on through some fairly difficult topics by the end, and we'll be doing looking at some of the rules of using powers to quite high level stuff. So we'll start off, as I say, by just saying what a power is. A power is a small superscript number, i.e. if I were to say 3 with a small 2 here, this 2 is a superscript, and it means if this 2 is the power, so it means 3 squared. You may have heard that before. What does 3 squared mean? The common misconception is that this means 3 times by 2, and it's not 3 times by 2. 3 times by 2 would simply be written as 3 times 2. So whenever you see a power, try and dissuade yourself from the illusion that it means 3 times by 2. What this actually means is 3 times by itself twice. Now, I'll say that again. 3 times by itself twice. So here's a 3, and we're timesing it by itself. So that's 3 times by 3. And the 2 means how many 3's we've got. So there's the first one, and there's the second one. Okay, so in this case 3 times by 3 is 9, which is obviously very different to 3 times by 2, which is 6. So we'll do another one just to clear up. 4 to the power of 3. This can also be said as 4 cubed. And again, this doesn't mean 4 times 3. It means 4 times by itself 3 times. So how do we write that? 4 times by 4 times by 4. So there's the first, the second, and the third 4. So this is what we're doing here. So 4 times by 4 is 16, and then we need to times it by another 4. So 16 times by 4, you can check it out on your calculator, but I promise you it's 64. Okay, so what about the next example? So 3 to the power of 6. Again, it doesn't mean 3 times by 6. That would be written as 3 multiplication symbol and a 6. This means 3 to the power of 6. So i.e. 3 times by 3 times by 3 times 3 times 3 times 3. So 1, 2, 3, 4, 5, 6 3's all multiplying themselves. So we could work this out as well, the first 2 3's, the second 2 3's, and the third 2 3's. So that's 9 times 9 times 9, which is 81 times by 9, and 81 times by 9 works out to be 729. So small numbers here, 3 times by 6 would be 18, but small numbers with powers rack up very quickly. The multiplications keep on going and going and going. We actually get quite high numbers from something that seems relatively small. So that's what a power is. That's enough examples on that. So we're going to move on next to using some rules of powers. So what do we mean by rules? Well, the first rule is the multiplication rule. So when we're using powers to times by another set of powers or something like that. So 3 squared times by 3 squared. How does that work? Well, if we were to do it normally, we'd just say 3 squared is 3 times by 3, and then we're multiplying by another 3 squared, which is another 3 times by 3. So then that works out to be 3 times 3 times 3 times 3, which is 9 times 9, which is 81. So that's fairly easy to do, but what happens if we would like to simplify this whole thing? Maybe we don't want to work all of this out. We just want to simplify this because there's a simpler way of writing this. So by using this part, we can see we've got 4 3's times in each other. So 4 3's times in each other, hopefully you'll agree, is 3 to the power of 4, because it's 4 lots of 3 multiplying itself. So if we go from this stage here straight to here, how does that work? Well, this 2 and this 2 add together to give this 4. So whenever we're multiplying, and this number here, the base number here, the big number that is the base number, and whenever that's the same and we're multiplying, we can just add the powers together. So we'll do that in another example. So something like 2 to the power of 4 times by 2 to the power of 3. Oops, sorry, that doesn't look very good. 2 to the power 3, there we go. Well, the first thing to notice is this base number and this base number are the same, so that's good. So what we can do to simplify this is say I'm going to add these powers. So 2 with a 4 plus 3 as a power, so 2 to the power of 7. This sort of thing can be just worked out on your calculator. So you can type it into your calculator. There's various ways depending on the calculator, but generally it'll be 2, the number, and then a button that looks a little bit like this, and then 7, or your calculator might have something like 2 x y and then 7, depending on what button your calculator uses. But maybe this second option will be the way forward. And if you were to write that into your calculator, it will tell you it's 128. You can do it by hand calculation, but that's basically it. This does work for algebra as well. So just a very quick example: x squared plus x3. Well, the base number is the same, although we don't know the base number, x we don't know. We can still say that that's the same as x2 plus 3, which is x to the power 5. Okay, so it does work for algebra. Okay, so that's the multiplication rule. The division rule is basically the opposite. Let's take an example: 3 to the power 5 divided by 3 to the power 2. Well, we could say that this is 3 times 3 times 3 times 3 times by 3. That's the 3 to the power 5, and we're dividing it by 3 squared, which is 3 times 3. Now, these 3's cancel from the top and the bottom because we're multiplying. This is all one multiplication, this is all one multiplication. So it's like saying 3 times 3 times 3, and then we've got this extra times 3 times 3, but then we're going to divide by that 3 times 3 as well, so they just cancel off. And then what we have left is 3 to the power of 3, because that's what we've got left here. So 3 to the power of 3. So how does that work with the division? Well, if you haven't guessed already, that comes from the powers taking away. So that's 3, and then the power 5 take away 2 here. 5 take away 2 equals 3 to the power of 3, which is exactly what we got up here. So when we're dividing, again, important thing, base numbers have to be the same. In this case they were 3, or the big number needs to be the same. When we're dividing, we take the powers away, the second power taken away from the first power. Okay, so one last example for that, how it could be useful. So 6 to the power 10 divided by 6 to the power of 8. Well, if you haven't got a calculator and you need to work this out, 6 to the power of 10 is going to work out to a very large number. Just to put it into perspective, it's actually about 60 million. 6 to the power of 10 is about 60 million. 6 to the power of 8 is about 17 million. So we're not going to be able to do 17 million into 60 million as a division, so there's just no point in trying. But what we can do is use our division of indices rule, which is base number the same, which is great, so it's going to be a 6, and then we're going to take the powers away. 10 take away 8. So that makes 6 to the power 2, which we can do, nice and easy, 36. So that's a good indication of how something like this can be, something like these rules can be really useful for simplifying a problem and saving yourself a whole heap of time. As I say, this is 60 million, this was 17 million, or somewhere around there. Okay, oh sorry, no, it was 1.7 million, not 17 million. But anyway, the problem is that we're not going to be able to do numbers like that. It's very hard to do. So anyway, that's the division rule. Hopefully that makes a bit of sense. The next rule that we're going to look at is the double powers rule, or the brackets rule, which looks something like this. If you have 2 squared and then brackets cubed, what does that mean? Well, this bit here means in the brackets 2 squared, which is 2 times by 2. 2 times by itself twice. And then we're cubing that. So anything inside this bracket we need to times by itself 3 times. So that'll be like this bracket multiplying itself 3 times. So there's the first one, there's the second one, there's the third one. So how do we do that? Well, that's just very pretty much 2 times 2 times 2 times 2 times 2 times 2. So that's 6 2's. So that could, hopefully you'll agree, simplified to 2 to the power 6. So how do we do that? Well, again, let's look at these powers. 2 and 3 become 6 by multiplying. So it's basically 2 times 3 for the power, which makes 2 to the power 6, which is what we've just proved here as well. So when we've got double powers here, we're going to multiply those two powers together to give this one this time, rather than before with the multiplication rule we were adding those powers. There's a bit of a difference there, so that's quite useful. I'll do one more, and we'll make it an algebra problem this time, just to show how easy it can be. So we've got double powers, x to the power 4 to the power of 2. Now, because it's double powers, what we're going to do is multiply those powers together. 4 times by 2, which is x to the power of 8. So it makes no difference that we don't know what the base number is. We're just going to stick it in there anyway as the x. So that's great. What we're going to do now is look at very quickly the combination of some of these rules. So 3 to the power of 4 times 3 to the power of 6 divided by 3 to the power of 4 squared. And we're going to simplify this whole thing down to just to 1 3 to the power of something, because at the moment this looks a bit messy. So first of all, your BIDMAS tells you that we'll deal with anything in brackets first, and we've got 2 sets of brackets, so we'll deal with the first set first. So 3 to the power of 4 times 3 to the power of 6, well, that makes 3 to the power of 10, because we're adding those powers together. And then we're dividing it by 3 to the power of 4 to the power of 2. But that's a double bracket, or sorry, a double power in the bracket, so we can times those powers together, so that makes 3 to the power of 8. And now what we've got is 3 to the power of 10 divided by 3 to the power of 8. Base numbers are the same. We're dividing, so let's take away. So that's 10 take away 8 as the power, so that's 3 to the power of 2. So there we go, that's that. Or we could even write it as the real answer. 3 to the power of 2 is just 9. So there's your square number there. Okay, so that's a combination rule. So it doesn't really matter what way round you do these, but sometimes a bit of common sense helps. You're not going to try and do the division when you've not simplified the bits on the left and the right of that division there. Okay, so that's the combination of these rules. Let's get rid of some of this then. The next topic that we need to look at, and this is where we get into slightly harder ones, is negative powers. Okay, so when the power is negative, and that looks something like this: 3 to the power of minus 2. What does that mean? It doesn't mean 3 times by minus 2 again. We'll just have a look at what it does mean now. So we'll take an example of what it actually means. So 3 to the power of 3 divided by 3 to the power of 5. What happens here? Well, it's division. Base numbers are the same, so we're going to take away. But this time we're doing 3 take away 5 because 3 comes first. And that makes 3 to the power of minus 2. So what does that actually mean? Well, let's take this and write it out of what it really means. 3 times 3 times 3 divided by 3 times 3 times 3 times 3 times 3. And now what we've done before, we cancelled the 3's, or the numbers on the top and the bottom. So what we end up getting is 1 over 3 times 3. But we know this bit means 3 squared. So it's like 1 over 3 squared. But that must be the same as this. So how does that work? Well, if the easiest way to think of this is if we take this minus and treat it as flipping the whole indice underneath a fraction line, so i.e. it becomes the denominator. So if I had to take that fraction, that negative, sorry, and say that means 1 over, and then I've got that whole thing without the negative underneath, so 3 squared. So basically that negative means that the whole thing is becoming, it goes underneath the fraction line there. Okay, and we'll have another little look at that on a different example here. So 2 to the power of minus 3. Well, what does that mean? Well, the minus again means 1 over, That's usually a nice way of thinking of it. And then the 2 to the power of 3 goes underneath, because that negative has just changed this whole thing into a fraction. Okay, so then 1 over 2 to the power of 3, well, that makes 2 times 2 times 2, which is 8, so 1 over 8. So that's how we deal with negatives. Okay, the next step that we're going to look at, the last rule, is when we've got fractions, i.e. something like I don't know, 25 to the power of 3 over 2 or something along those lines. What does that mean? Well, if we take an example, first of all, 9 to the power of 1 over 2, well, this means the 1 is the normal power and the 2 is how many roots we need to find. So i.e. Let's take the 9. So 9 with a normal power of 1, 9 to the power of 1, it just equals 9, which we know. So that's fine. But now we need to deal with this 2 underneath, this denominator of the power. And that means we need to find the second root, i.e. the square root. So we need to find the square root, sometimes we put a little 2 there, square root of 9, which hopefully we know by now is 3, because 3 times 3 makes 9. Okay, we'll do another example. So let's take that other one that I was just looking at before. 25 to the power of 3 over 2. Well, this means 3 is a normal power, as we said before, and 2 is the root. Now, does it matter what way round we do this? No, it doesn't. But if we look at it with a bit of common sense, 25 to the power of 3, i.e. this normal power here, that's very hard to do, especially in your head or on paper. It's going to take a while. So let's just write not easy for that bit. So instead, let's do the root first. It says 2, so it's the square root of 25, which is easy. We know that's 5, because 5 times 5 makes 25. Okay, so now we've done this bit, we can now do this power of 3, the normal power. So 5 to the power of 3. In fact, I shouldn't write it like that. I should write 5 to the power of 3 equals 5 times 5 times 5, which makes 125. You can get that on the calculator if you wish, but that's how we do that. So yes, it would have been possible to do it this way first, but just to show you how hard it would have been, you'd have then had to find the square root of 15,625, which is not really that easy. So sometimes it does pay to sort of spend that first 10 seconds, 15 seconds of deciding which one to do first, i.e. the top bit or the bottom bit. But the important thing is the bottom is the root and the top is the normal power. So let's do one last question on the fractional stuff. 64 to the power of 2 over 3. So this means the third root, i.e. the cube root, and this means squared, or power of 2, normal power. So what are we going to do first? Either 64 squared, or cube root of 64. What one seems easiest? Well, 64 squared is a fairly large number, it's not going to be easy to do. The cube root of 64, could argue that that's quite difficult as well, but once you get to know these numbers a bit more, you'll find that the cube root of 64 is just 4. So that's a nice easy number to remember. Okay, so this is the one that we won't do, and this is the one we will do, because now we've got a 4. But what do we do with that 4? Well, it says up here in the power, we've done the cube root, now we need to do the square. So 4 squared, which equals 4 times 4, makes 16. So hopefully that makes a bit of sense. Just to top all this off, it is quite difficult. We're going to do a combination one of negatives and fractions. So 121 to the power of minus 1/2. So how do we do that? Well, first of all, what I'm going to do is completely ignore this negative, but I'm going to come back to it. So how do I do 121 to the power of half? Well, 121 to the power of 1 is just 121, so that's nice and easy. And then we're going to do the square root, because that's the 2 here, of 121, which is 11. Okay, so now we've got 11. I've done that bit, now I'm going to come back to this negative. So what do I do with a negative? Well, it means 1 over, and then whatever the number is, so 11. So hopefully that makes some sense. Clears up a few of the rules of indices. You can have a practice, there's loads of questions available. So have a practice, and thanks very much for listening. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah, would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give that another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.